1-3, extra practice for Algebra 1, big ideas. In this section, we're going to deal with ratios and proportion. So it says solve the proportion. There's a number of ways to do this problem. And we're going to go over a handful of them, different options. You can do cross product. You know that all ratios. So you can multiply across diagonally. And then instead of multiplying these, I'm going to automatically divide by 72, because if I can simplify before multiplying, I think that's always better. So what goes into 24 and 72? 8 goes into that. 8 goes into 72 9 times. 8 goes into 24 3 times. And then 3 goes into both of those. So 3 goes into that once. 3 goes into this 3 times. And then 3 goes into 54 also. 3 goes into 50, 3 goes into 3 once, 3 goes into 54, what's that, 18 times? So I get A equals 18. That is one method that you can do. You can also look at this as an equation just to start off with and multiply both sides by 24. What gets rid of a 24 in the denominator is a 24 in the numerator. So we're going to multiply by 24, and that gives us A. And we have the same numbers that we were simplifying. 24, 54 over 72, same 24, 54 over 72. So really both options, or both ways to do this problem, produce the same mathematical equation. So I'm going to make sure that 24 times 54 divided by 72, that's 18. Good. So we were good. Number 2. Let's, again, we can do it a number of ways. I'm going to choose to do cross product. Just it's more maybe of a traditional. I don't care which method you do. I just need you to show your work. So what I am not going to do is multiply 4 times 10.8. I'm not going to do that. I'm going to do this part of it first. So I'm not going to do problems or work that's going to create more work down the line. So what goes into 4 and 1.2? Well, 1.2 we need to understand is just like 12. And it's just 12 over 10. So I see that 4 goes into 4 and 4 goes into 1.2. So 4 goes into 4 once, and 4 goes into 1.2 0.3 times. So I like that. To me that looks, and I'm okay with that. I can sort of see the logic of that. Hopefully you can see the logic of that. And we know that 3 goes into 108 36 times. So these are mental problems. Numeracy, you should be familiar, number sense, and being familiar with this. These are numbers. You don't need calculators. You can use a calculator to check, but we should be utilizing some of these mental math problems. Divide by 5, divide by 5, you get Q equals, now 5 doesn't go into 13 or 4, so I will have to multiply the numerators. And that's going to be 52 over 5, which is an acceptable answer. I don't mind it. Doesn't say, it just says solve the proportion. I like that. You can get 5, you can get 10 and 2/5, or you can get 10.4. These you have to do work to get to. I don't have to do anything more than multiplying 13 times 4. So I'm always going to do 52 over 5. What did they write as the answer? What's number 3? No, they said 10.4. All right, well, they did a decimal. Good for them. Doesn't mean that mine's wrong. Let's multiply across here, and we get 14 times x equals 56 times 10. Divide by 14, divide by 14. We get x equals, I can cancel these, 7 and 5, and 7 and 56 goes 8 times. And that's 1, so we get 40. Yeah, 56, yeah. Just making sure on my times tables. Good. You need to climb to the top of a house. You take the measurements shown, the right angles, the right triangles created by each object and its shadow are similar. Can you use a ladder that reaches heights up to 13 meters? So I have a ladder that is 13 meters tall. Can I use it to get to the top of the school? Can I get up here? All right, well, we have 2 triangles. They know that this is similar to this. So the the shadow, yes, the shadow of the object, so, sorry, we're going to do the school. So the school's units are going to be the shadow over the height. So the shadow is 8.8 meters, and we don't know what the height is of the school, and then the person, the individual, its shadow is 1.1 meters, and its height is 1.5 meters. All right, since the units are all the same, I don't have to do anything more than that. So I'm going to do cross product. I'm going to multiply these 2 times these 2, and that's going to give me 1.1x equals 8.8 times 1.5. I'm going to divide by 1.1, divide by 1.1. That gives me x equals, and we can cancel this. 11 goes into this, or 1.1 goes in this 1 times, 1.1 goes in this 8 times. So that leaves me with 8 times 1.5, which is 8 times half of it, which is 12. So that is 12 meters. So this height is 12 meters, and if I have a 13 meter ladder, can I get to the top? Yes. I can use the ladder to get to the top. Of the school. Word problem, word answer. Table shows oh, there we go. The table shows statistics for a basketball player. Use rates, any rates, to compare the player's performance between the 2 seasons. Well, I'm going to assume, I'm going to pick one of them. There are many that I can pick. I'm going to pick his 2-point shots, which might be different from his 3-point shooting, but I'm going to just use the 2-point, and I'm going to compare the first season to the second season. And here's the important thing is the ratio. We got to pick a ratio that represents good, so it has to be made attempts made over attempts taken. Attempts, well, and that's going to be a representation that I can compare that tells me whether he is improved or not. So, I guess we'll do that twice. We'll do it each time. So we'll take first year and attempts made over attempts taken. And this is the second year. So in year one, he made 131. In year two, he only made 72. But year one, he took 292. Took a considerable more attempts and 185. So we're going to change that. This is the one time I would convert it to a decimal or a common denominator so we can compare the numerators. So we're going to make a unit rate, 131 divided by 292. So he made 0.448 made for every one attempt, which is pretty good. And now let's look at 72 divided by 185, and that's 38.9 made for every one attempt. So which one's better? Well, your first year was better for 2 point. So he had a better use rates compare the player's performance between the two seasons. So this was the better year. He had better make the first year than the second year. He fell off the second year. Might not be the case for 3-point attempts, but I just chose to do it for one of them, and you just need to explain it. So exercise 7 through 10, complete the statement round to the nearest hundredth if necessary. So we have 30.9 inches, and we're going to convert it to millimeters. So I don't necessarily expect you to know that conversion, so you see that it was provided. We know that 1 inch is equivalent to 25.4 millimeters. So inches need to go down in the denominator. My unit is 1 to 25.4 millimeters. And we like this because inches cancel. And now I'm going to multiply those two together. So we have, well, we can do two ways. Let's do 25.4, not using a calculator. 30.9 just for practice. 9 times 4 is 36. 9 times 5 is 45, plus 3 is 48. 18. 9 times 2 is 18, plus 4 is 22. We have for the 0, and now we go to the hundredths or the tenths place. We have 3 times 4 is 12. 15, 3 times 5 is 15, plus 1 is 16. 3 times 2 is 6, plus 1 is 7. 6, 8, 4, 8, 7. And we have 1, 2 decimal places, so it starts here, 1, 2, and that number is going to be 784.86 millimeters, round to the nearest hundredth, so that goes out to the hundredth place, so we're good. 784.86. Let's check by using a calculator. 25.4 times 30.9, 784.86. We have 64 quarts, and we need to get to fluid ounces. So again, I don't necessarily, maybe it's, you should maybe know, I'm okay, 32 ounces. Some people would say that you would need to know quarts to ounces to quarts, but we'll see. 32 times 64. 64 times 32 is 8, 12, 12, 19. So equals 8, 4, 2,000, 48 fluid ounces. Because ounces is a weight also. So ounces can be a unit of volume and it can also be a weight. So just be careful of that. Let's check real quick. 64 times 32 equals 2048. Good. Fluid ounces. 4 liters, 44 liters is approximately, and because it knows that we're going to have to round, so liters goes in the denominator. 1 liter is 0.264172 gallons. Liters cancel. You're going to multiply. I'm not going to round yet. I'm going to use these units. I'm going to put the decimal up top, and I'm going to round after. So 8, 28, 6, 16, 24, 25, 8, 10, and then I know that those numbers are going to repeat because I'm multiplying by the same number. 8, 8 and 8 is 16, 7, 14, 15, 13, 12, 6, 1, 1. We have 1, 2, 3, 4, 5, 6 decimal places. 1, 2, 3, 4, 5, 6 decimal places. So we get 11.623568. Okay, and now it says round to the hundredths place. So we're going to round to this place. We have to look at the thousandths place to see if I'm going to round my hundredths place up or down. 3 tells me that I'm going to round down to 62, and that's going to be gallons. So 11.62 gallons. Miles. So notice, and yeah, I mean, again, some people would think that you should know how many feet are in a mile. That's a somewhat commonplace. And now we're out of miles in feet, but we got to get to inches. So I have one more conversion box that I need to do. 1 foot, 12 inches. And that cancels the feet into inches. And so now we're multiplying 0.2 times 5,280 times 12. Yeah, I mean, I guess I'm going to do 0.2 times 12, which is 2.4, and then I'm going to take 2.4, we're probably going to do this, 5280 times 2.4, and let's do that. That's 0, that's 32, that's 8, 11, that's 21, that's 0, that's 16, that's 5, that's 10, 0, 2, 7, 6, 2, 1. We have 1 decimal place, so it goes there. So that should be 12,672 inches in 0.2 miles. Yeah, it sounds, I guess it sounds somewhat reasonable. Reasonable, yeah. So that's my unit. Lake A evaporates at an average rate of 18 quarts per day. Lake A is 18 quarts per day, 1 day. Okay, and Lake B evaporates at an average rate of 0.005 gallons per minute. So we have to choose one of them to convert to. Do we want minutes? Well, it depends. So, I don't know. Well, let's convert A to B. Let's convert quarts per day to gallons per minute. And I don't mind writing this at the end here so I know what we're moving towards. So here's my first conversion box. Let's do what is comfy, days to minutes. So that's going to be days to hours first, and then hours to minutes. So 1 hour, 60 minutes. So we're out of days, we're out of hours, and we're in minutes, which we have to get to. Now we need to go quarts to gallons. And we knew there's 4 quarts to 1 gallon. Pretty sure that's correct. Quarts to gallons. We can always check. Come on, Chrome. Come on, Chrome. We can type quarts to gallons. 1 quart to 1/4 of a gallon, or yeah. 1 quart is 1/4 of a gallon, right? So 4 quarts equals 1 gallon. 4 quarts, 1 gallon. We're good. Oh, sorry, breaking my audio. Okay, and so that gets rid of quarts in the denominator and the numerator, and we're in gallons, which is great. Now we have 18 in the numerator, 18 gallons for 24 times 4 times 60, that's 24 times 240. That's 0, 16, 9, that's 0, that's 8, that's 4, 0, 6, so 5, 7, 6, 0 minutes, but we need a unit rate. It is per 1 minute, so we're going to take a little shortcut. We're going to do 18 divided by 57760, which gives us 003125. 003125. I think it was 2 zeros, yeah. And this is gallons per 1 minute. And this is evaporation of Lake A. Lake A evaporates. So it evaporates smaller amount than Lake B. So that's slower. So let's look at the question. Which lake evaporates at a faster rate? Well, Lake B does, because you're evaporating more water per minute than Lake A. So Lake B evaporates faster. Describe and correct the error in converting 3 feet to centimeters. So we have 3 feet, and if we're going to do our conversion box, we're going to go, okay, feet to inches. I'm okay with that. And then you need to go from inches to centimeters. So I'm okay with that. So the unit canceling is correct, right? Inches over feet, centimeters over inches. Now we just need to, right? That gets out of there, that gets out of there, and that leaves us with centimeters, which is good. Now we just need to know the unit. So I know that there are 12 inches in 1 foot. 12 inches, 1 foot, so that's okay. This is okay. And now we need to check centimeters and inches. So we need to see how many centimeters are in inches, etc. So let's do inch to centimeter. 1 inch to 2.54 centimeters. 1 inch. There we go. So we see what our problem is. It's actually 1 inch to to 2.54 centimeters. So they messed up their conversion. Okay? And correct the error. So we have to not only do it, but we also have to correct it. This is relatively easy because all of our values are in the numerator. 3 times 12 is 36 times 2.54. 2.54 times 36. That's 24. That's 32. That's 12. That's 15. That is 12, 16, 7, 4, 4, 11, 9. 2 places, so 91.44 centimeters. Let's check our math. Let's check 2.54 times 36. 91.44. Okay, good. The graph shows the relationship between centimeters and micrometers. Use the graph to convert each measure 7 centimeters. So 0, 1, 2, 3, 4, 5, 6, 7. So I'm going to go up and I'm going to see where does that go over here. And we're 10,000 increments of 10,000. So that is going to be 70,000 micrometers. That's nice. 7 centimeters is equal to 70,000 micrometers. And now let's do this. Let's 35,000 micrometers to centimeters. So if this is 35,000 is going to be halfway. And then we will come down here, and that would be 3.5 centimeters. Cool? Good. That's a good one. I like that. Interpreting graphs. And those are all your answers. All right. Hopefully you had a good practice. Hopefully this was beneficial to you. Enjoy.